Hi guys, welcome to this video on Can an AI agent do data science? I'm a working data scientist and I've been wondering for a while now which parts of my job an AI agent could do. Some machine learning, whether it can do any data visualization but for a more interactive style plot, and also taking on board some of that stakeholder communication so that we could put the skills of a data scientist in the hands of a non-technical user. Whether it can write code in a notebook style where the state is preserved between code invocations and it's auditable. What you're going to see in this video is me trying to find a data set that will work as a test bed. I'm then going to put that data set through ChatGPT to see what our baseline is, to see how well ChatGPT does. And then I'm going to get stuck into building an AI agent to do those three things: data visualization, code executed in a notebook fashion, and machine learning. I'm going to be using LangGraph for the agent building backend, Streamlit for hosting a development frontend, and Plotly for interactive charts. At the end, I'm also going to finish with a discussion around what parts of my job are safe and what skills I can see that are going to be valuable in our agentic future. We're also going to see some advanced techniques, both in LangGraph for state management and debugging, and for Cursor, it'll be rapid prototyping with Streamlit. So stay tuned and let's get stuck into finding our dataset. So I've headed over to Kaggle to try and find our dataset, and I was drawn to this one at the bottom of the page now, which is this financial transactions dataset. And the reason why I was drawn to this one is because it's multiple files, which means there's probably going to be a join that's required, which adds an extra level of complexity. It's also, not too large, not too small either. So it's large enough that ChatGPT is going to have an issue with it. And I think it's a real world data set. So there's going to be some noise. There's not going to be perfectly curated data for a toy problem. So that's the data set that I'm going to be focused on, and we're going to be exploring in further detail. Let's have a look at it and see what it contains. So this is just a quick overview, and you always get this page on Kaggle about the types of data that's in this data set. So we've got transaction level data, some data about cards. We've even got some fraud data if we want to use that for some classification, good for a machine learning problem. And it's even, which I quite like as well, it's got some use cases and applications for the data at the bottom, so we kind of know what we're getting ourselves in for. So that's the data set I've gone for. Let's take a quick peek at what each of those data sets looks like. First up, we've got the customer bank cards data, and this is for every single customer in this data set. How many bank cards do they have? When to expire, what type of card it is, that type of information, and I guess the credit limit and if they're in any debt on that card. So that's the first one. We've then also got the customer details. This is your demographic information about the customer, their retirement age, birth year, current age, birth month, that type of thing. I'm not really too interested, to be honest, about exactly what's in the data at the moment. It's just a test case to see how well we can go with the visualization, but that's the next one. We've then got the transaction level data, and so the other reason why I quite like this data, because the language model to use this data with one of the other data sets would have to do a group by on or a join and then a group or some sort of aggregation in order to be able to use it. Now let's take a look at how well ChatGPT does if I upload this data and get it to tackle problem relating to estimating a customer's lifetime value. So we've got an initial issue here, which is that one of the sizes of the data sets is too large, and that's one of the things I'd like to sort out with this agent. And then I'm just asking it to analyze the customer lifetime value. And so we've only got the two data sets that it's been able to upload. And so it's giving us the information that's stored in each of the data sets, what's in the cards data, what's in the users data, and it's given us some next steps, which I quite like, this idea of it providing us a walkthrough of what it's going to do before we actually then sign off on it and it can continue. So I'm happy with what it's going to do, and it's then going to continue and now perform this estimated lifetime value. Per capita income, credit limit and debit levels. Sounds very reasonable. Right, so we've got our results and it's calculated or estimated the customer lifetime value. And I'm not quite sure, this is a bit of a trick question because I don't know how it can really estimate the customer lifetime value for a bank, or when it doesn't know how this business generates its revenue. So this is a relative measure based on massive assumptions that are definitely not based in facts about the business. So that's one immediate reason why data scientists are not going to lose their job at the moment, because ChatGPT has no idea, or the language model at the moment has no idea why it's doing this analysis and what the outcomes should be. It might be very good at doing the analysis if you give it clear instructions, but it can't work with limited information and try and ask questions to gather the remaining information. So it's asked if I want any specific visualizations, and so I'm just going to get it to plot a generic distribution to see what we get out, because I'm curious to see. So I've been pretty loose plotting the distribution. It's assumed that I'm in customer lifetime value, which I did, but it's now produced a matplotlib chart, which it looks like, which is a common library in Python. However, it's also specifically said that interactive charts aren't supported. And that's something that I'd like to do with Plotly, because interactive charts make it so much easier to really dig into the data. And also you then can add in widgets for sliders for adjusting filters and things like that, more akin to a Power BI report rather than a static picture of a chart. So that's what ChatGPT's attempt has been, and honestly it's not actually that bad, but I know from previous experimentation as well that the code never persists. So if I was to write another message now, if it wanted to do any deeper analysis on top of that, it would have to re-execute the code again, and it would be a brand new execution environment, which is something that I'd also like to tackle here. So persisting the code state and the variables through from message to message and analysis to analysis, which is kind of what enables us to do really deep analysis in a Jupyter notebook. So now we've got our data set, we've had a quick look at what ChatGPT has been able to do. Let's get stuck into building our agent. So just a quick one, if you're not familiar with Plotly, it's an interactive graphing library in Python that allows you to create plots. It's also got a good API that's quite easy and practical to use, which is important because we're using a language model. I actually find matplotlib a little bit jarring to work with sometimes, whereas Plotly has a nice high-level library called Plotly Express, which gives you access in a similar way to Seaborn, a lot of pre-packaged and ready-to-use charts. So that's hopefully what our language model will choose to use rather than going into the same level of detail as matplotlib. Now let's get back to our agent building. Right, so to get started, I'm going to set up a Streamlit data upload and display. I'm going to be using Cursor to get the front end looking and feeling right as fast as possible. First, I've gone and created our entry point to our Streamlit app. And I like to have this in any Streamlit project because it means I can have multiple pages and I can store them wherever I want to store them. You can also customize things like the page icons and the layout, and I always go for wide because you can just fit more on the screen. And given I mainly use the Streamlit apps for debugging, the more screen space, the better. So that's what I've set up here. And next I'm going to go into a new file, this Python visualization file, and use Cursor to create our front end. So let's take a look at how that works. So I've gone in and I'm pressing Control K to use Cursor's and I'm asking it to create a page with the ability to upload CSV files because that's the format of our data. And I'm specifying as well that those files are stored in a local file system. So after they've been uploaded, they're always available for me to use. I don't need to upload them every time I refresh the Streamlit page. I'm also specifying that the user can select one or all of those files to be analyzed by our agent. I'm being quite specific, and I found that the more specific you are, especially with these types of front-end generation, the better job it does and the faster it is able to do it. I specified the library I want to use, pandas, and I've also specified that I want the dataset to be visible so that after you've uploaded the data, you can make sure it's what you expect. And here we go. It looks pretty good at first glance, and next we just need to actually get it running to see what it looks like. So the command that I'm running is streamlit run data analysis. This is the name of the file, and then the max upload size. And so otherwise Streamlit caps us at about 200 megabytes. By doing this, it means we're no longer capped and we can go up to 2 gigabytes. That's how I ran it. Let's take a look at what it eventually looks like. So I'm able to browse for the files like I expected, can open them. Taking a little while to upload the larger file, which I think is about 1 gigabyte. And then I've got this drop down where I can select, there we go, can select all of our files. Perfect. So I've hit go, and now I have short summaries of our data sets so that I can manually inspect them to confirm they are what I expect them to be and there's not going to be any issues. So that's a good start. I'm able to view the data similar to how ChatGPT does it, but in a more of a structured way rather than it just being dumped into chat, which I think makes life a bit easier. So we've got our data uploaded and stored and we're able to view it in a Streamlit dashboard. Next up, what I want to do is just incorporate the chat into the front end and not worry about the back end. So let's get stuck into that. Right, so we've now got our data being uploaded to Streamlit. We now need a chat front-end component that will eventually then connect to our agent. So let's have a look at what I've done. I've started by creating a class to represent our input data. So we've got a way to pass data from the front end to our agent. And I've also created just a dummy class at the moment so that we can mock out the back-end functionality and fill it in later. There's only two functions. We've got a user sending a message. So that's when the front end receives a new message from the user, it can send it back to the agent for processing and getting a response, and for resetting the chat as well. So it's a very simple class, and that's going to be where we build our agent in the later steps. What I've done next is I've then created the chatbot window within Streamlit. Streamlit provides a few different components that make this quite easy to do. The two components I'm using are this chat message component and this chat input. The chat message component, it displays the chat messages on screen like if you were messaging on WhatsApp or Facebook Messenger or something like that. And the chat input provides a way for you to input chat as a user and for this function to be called when that message is submitted. So this function up here gets called whenever we hit enter on a message on the front end. And what happens then is we create our input data objects so that they are passed to the backend, and we call our backend class, which is this Python chatbot, with the user sent message function. That's all we need to get our front end up and running with Streamlit. Let's now take a look at what it looks like. So it's the same front end as before, where we can select our data and then enter messages within the chat window below. So I can just say hi, and at the moment we haven't configured the backend to do anything other than just to store our input messages. So that's what we've got. We've got the messages we're sending appearing on screen, and this component here where you see the Y and the hi, this is that chat message component by Streamlit. And this is the chat input component at the bottom where you hit enter by Streamlit. Right, so we've got our chat component set up. Let's get stuck in and start building our agent. In this part of the build, we're going to be creating our React agent. And I'm going to be using predominantly LangGraph to do this. If you're not familiar with LangGraph or what a React agent is, I recommend you check out my introduction video to LangGraph, as that will be able to cover the basics and most of the theory. Right, let's get stuck in. So this is a high-level overview of what our agentic graph looks like. We've got our input state, which is where we keep track of all of our variables. We've got our chat prompt and our chat node, where we're using OpenAI. And we've got our tool nodes, which is where all of our language model tools are stored, and we're able to deal with the outputs, add them to the state. Let's take a look at the code that we use to create our main chat node. We start by creating the prompt, which I've split into three sections: role, capabilities, and goals. I always like to include the role because the language model has been trained on a lot of content from across the internet. So it will have read blogs and articles written by data scientists, so it knows and understands how data scientists like to communicate. So if I tell it that it's a professional data scientist, it will communicate in the same way, and it'll condition it to start using that type of language. I've also included the tools that it's been provided with. You don't need to include this in your prompt, but I find it helps because it means I can reference these tools in other parts of the prompt. And then finally, I've listed the goals so that it's got a priority list of all about what it's trying to do. It's going to get more complicated later on, but this is all we need to get started. So let's start there. Now let's take a look at the code we're going to use for the same part of the graph. I've created three files to house our LangGraph logic. One which houses all of our nodes. So that'll be our tool node and our main chat language model node. I've got a state file which will store our graph state, and a tool file which stores all of our agentic tools. Also included in the nodes file is what I've got here, which is this kind of preamble where I define the language model we're using, the tools. I associate the tools to the language model with bind tools. And I'm using this tool executor class, which is just a way of executing these functions behind the scenes in parallel. It's compatible with some other LangChain classes. I'm loading in our prompt, and I'm then using the prompt in this chat prompt template class, which is just a convenient way of passing our variables into our prompt. Next, I've got our main chat node, which is defined here, and that's what it looks like. And all that's happening here is we're just invoking this model that we've defined up here with our current state of the graph. The new messages are being added to the graph afterwards. Let's take a look at our state. In the state, all we've got is one variable here, which is our messages. And the reason we've got these annotated and sequence classes is so that when we return a single list from one of our nodes, it gets added to the global state list. I only have to return the new message created in that node. And lastly, I'm creating the tools node. Now there's quite a bit going on here, so I'll take you through it slowly because this is one of our top tricks for using LangGraph. The reason why I've got some custom tool node here is because I want to be able to pass in the graph state to every single tool by default. And I also want to be able to update the graph state from within the tool calls. So what I'm doing here is I'm creating tool invocations for every single tool call that's been requested by the language model. And I'm sending them into this batch executor, which executes them in parallel behind the scenes with error handling. I'm then looping over all of the responses from the tool calls. I'm creating new tool messages based on the responses, which will be added to our messages graph state. And I'm also extracting any other state updates that have been returned from the tool node so that I can compile all of those state updates from every single tool call and perform one state update when I return these state updates from the node. Let's now have a look at our tools, or our tool. We've only got one, which is to execute some Python code, which at the moment we're just taking in Python code. It's just a dummy class at the moment with this doc string to be able to provide some contextual information to the language model. I'm using the LangChain @tool method here and specifying that I do want to include the doc string within the function definition that's passed to the language model. So that means the language model will be able to see this doc string. Great, so we've defined our tool. Let's now have a look at how we build the graph. So now we're going to connect everything together, connect all the nodes, add the edges, create this conditional edge so that it knows if it should route to the tools or if it should route to the end of the graph. And so that's what's happening here. I'm creating our graph with this agent state class, which I've defined earlier. I'm then adding our two nodes, the prompt node and the tool node. I'm adding a conditional edge, which is this here, which will either route to the end of the graph or it'll route to our tool node. We haven't seen this function here, but this looks very similar to all of the examples on LangGraph's website or in any of my other tutorials, so I'm not going to go into detail. The code is also available in the description if you want to check that out. So I'm adding our conditional edge here, and then I'm adding another edge that goes from tools back to our agent. And finally, I'm setting our entry point to be this node here, our agent node, so that when we start, we always start at this node. Finally, I'm compiling, and then we're setting it onto self.graph within the chatbot. Great, we've got our graph, but we now need to make our data visible to our agent. And I'm still going to be using LangGraph and Streamlit because we're going to have to do some refactoring on the front end. So let's get started. So you'll remember this input data class from earlier, which I created to store our data in. So we're going to be using that, and I've created an extra field on our graph state for storing the input data. So that's represented here. Now let's have a look at what this is going to look like. So I've updated the main node in the graph, that's this one here, so that it will first create a summary of the data that's available, and will then pass this as an extra message into our chat history. So it's like us saying to ChatGPT, here are all the data sets I've got, and then uploading them, but we're kind of doing that first. And all we're going to be providing is a description of the data and the name of the variable, which we'll use in a later step. So ignore this for now. This does get used in a later step of this tutorial. So that's how we're providing the information to our language model. Now let's refactor our front end to be able to provide this information to our backend. Right, now I want to get our front end code to be able to take the data sets that we've specified and pass these through to the agent when the user sends a message. Let's see how it's done. So I've selected the whole thing, and I'm then referencing the data dictionary so it can load in the descriptions of the data and the file names and use these to create the input data classes to pass to our backend. I'm also asking it to display the dataset descriptions on the dataset tab of our front end. I've also been getting a little bit frustrated with having the chat directly below our dataset management, and so I'm asking it to just move all of the chat stuff onto a separate tab so it's out the way and we can swap between them more easily. I think it makes it a bit more natural to interact with the UI, so I've asked it to do that as well. There we go, it's come out with something. I'll have a quick scan of it and then we'll see what it looks like. All looks good to me. I think we'll accept those, and let's take a look at the front end. So let's select a few data sets. That looks good. We've got our dataset information below and no longer our chat component there. That will have been moved into a separate tab. Let's go on to the separate tab. Now let's ask a basic question about what's in the data. We haven't hooked up anything complex or Python execution yet, but it should at least be able to tell me what data is available. Nice, so it's correctly told me the data sets that are available, and then it's gone on and hallucinated some details about fields that may or may not be in the data, which is completely irrelevant, but we're going to sort that out in the next step when it's actually able to execute Python code and query what fields are available within the data sets that it's got access to. So let's get stuck into that. Right, so let's get into the next part of our build, where I'm getting our agent to execute code. I've started by updating our prompt. I've added code guidelines to just constrain the output of the language model to make it easier to get the right answer. I've told it can only use 3 libraries: pandas for data management, sklearn for machine learning, and plotly for visualization, so I've kept it really simple. I've also specified that it needs to use print statements for logging, and there's 2 reasons for that. There's one which is to make it explicit, so the language model has to actively choose what it wants to see when it's writing its code. And the other is that I was having issues with the language model trying to use things like pandas.head or pandas.describe to get the outputs and expecting the outputs to be there. Let's see how we're going to adjust our agent. I've added one new field, intermediate outputs here. And what we're going to use that for is that when we've executed our code, we're going to store the Python code that was executed and also the output from that Python code. So that when we're when we're using the chatbot and we want to know what code was executed, we can then have a look and see where it went wrong or where it went right. It makes it more auditable in general, and it'll help us debugging the agent. Now let's actually create the code for our tool. It's called complete Python task, and so we had a dummy function before, but now I'm filling it out with this exec, which is going to execute the Python code that the language model has used to populate this function call. I've also added a thought argument, which means the language model now has to plan out the code that it's going to write first before actually writing the code. The code gets executed, and we're encapsulating where the code's executed inside this try except loop, so that if there's a mistake and the code execution fails, the language model has another attempt at writing the code. And we're storing the thought and the code so we can debug them in our UI. Let's now edit the backend code so that it can handle the intermediate outputs for debugging. And I'm going to be using Cursor for this again. So I've highlighted the whole thing, and I'm referring to the 2 files that I know Cursor should have access to be able to make this change: our tools and our state file. So it will then know what classes are available to use. So it's correctly identified that we need to deal with these new immediate outputs and that we need to store any new immediate outputs on our backend. Great, good job Cursor. Now let's move on to editing our front end. So similarly for the front end, I'm going to get Cursor to edit the entire thing. and I'm going to ask it to display the intermediate outputs for debugging on a separate tab again, so that if we want to, we can dive in and have a look at those intermediate outputs. And it's labeled the new tab debug, and now we've got our brand new tab that's looking pretty good, and it's going to display the thought process, the code, and the output of the code. I'm also going to log our intermediate outputs from our main language model node in the graph. The reason for that is I'd like to be able to see the data message that has been created in case I need to debug that. So this is really for storing any information that's created in the graph or variables that I'm not going to have visibility of after the graph is finished executing. So let's take a look what it's going to look like. I'm selecting our data as before, going to our chat interface, asking a more detailed question about what fields are in the data to see if it can pull out and do some basic analysis by listing the columns. So it's been able to read it in and it's found the correct field names. They look correct. Nice, good job. And it's listed the field names for both. Nice. Now let's have a look, see if our debugging has worked. That's our data message, that's correct. And on the next drop down, I think we'll see our code. We'll see our thought process. It said to understand the fields, I will load it in and inspect the first few rows and column names. Perfect. And it's then importing our library, loading in the file, and displaying the column names in the first few rows. That's exactly what we want to do. The only issue to me is that it's having to load in this file every single time, and there's a lot of room for error in getting the path name correct here. So what we're going to do in the next stage is preload all of the data into variables and persist the data in between states so that once it's done some analysis, it won't have to redo that analysis. Right, so let's move on into persisting the variables between code executions. So we've got an AI agent that can write code, but it's very static and it can't produce plots. So let's now try and make the variables persist between each code execution. And we're going to be using Streamlit and LangGraph as before, and there'll be a few more snippets using Cursor about how I'm refactoring. So what I'm going to change is add an extra field to the graph state, and that's this current variables dictionary, which means that as it's going around the loop, every single loop, those variables get injected back into our Python interpreter so they can be reused. I think is really the secret sauce about why Jupyter notebooks are so useful and why this process works really well. So let's see how we've done it. I've updated the data summary from just adding the data sets that we're using at the top to now including the variables in the state. So now the LLM knows what the current state of the interpreter is, what variables are available for it to use, and what it might need to recreate. So this is going to provide a really useful context about the code and what's happened before. And because this is going to be the most recent message in the context history, it's going to be more useful than just being able to see the code that it's written previously because it's in more recent memory. So it'll more strongly condition the language model's output. I've also updated the prompt to include some extra information about what we're doing. So I've told it that all the input data is going to be preloaded, so it won't need to do any reading of files, and also that any variables it creates are persisted, so it can reuse and it can plan around that. And I've kept it in the same format as the rest of the prompt, which is really important. Next, I've then updated our Python tool. And there's quite a lot going on here, so let's go through it slowly. At the top, I'm taking the variables that were available before because I'm loading them from the graph state. And I'm also loading in the CSV files from the graph state as well. So we're preloading the data and we're loading the previous variables that were used. I'm also updating a dictionary, which you can't see in view, but it's a script variable. And so we're updating this additional variable just so they're persisted between graph invocations, but we're using these current variables on the graph state so that if the tool is executed multiple times in a single graph execution, then those variables will persist. So we're persisting them in two locations, but for two different purposes. And finally, the new variables that have been returned, I'm also returning in the updated state so that the next time this tool is executed, it will have access to them. Now let's have a look, see how well it does. Let's select our data again and then go into the chat interface. And I'm going to try with something a bit more complex this time. I think I'd quite like to have a go at trying some machine learning. So I'm asking it, can you help me reduce the churn? Which is a very high level request. And so this is the typical request that you might get working as a data scientist. You're given a very high level KPI and expected to then run with it. So I'm hoping that our agent might be able to do something similar. So that's not a bad start. It wants to define what churn is, which is useful and really important. Different businesses are going to have different definition of at what point they consider a customer to be churned. But in general, the process seems pretty good, and it's suggesting that we might want to use a machine learning model, which is perfect. So let's see how well it does. Great, so it's loading the data set and it knows what it's working with. And it's now asking me what is churn. So it wants a definition of churn to work with so it can construct a label for the data. And so it's saying it wants to use the last transaction date and churn threshold date. Sounds pretty good because it's found some fields that correspond with some existing variables. So let's go with that. So what is our output then? So it's managed to calculate the last transaction date. And it's saying that customers who haven't transacted since a churn date will be considered churned. Just said, let's go with that definition. I'm more curious to see how far it can get. Right, so what's it done? It's defined a churn threshold date 6 months before the last transaction in the data set. And then it's using that to identify if customers churned. So it's now saying we need to create additional features, but let's take a quick look at the output to see what it's done. So it's saying the last transaction date is less than the churn threshold date, which is 6 months after the last transaction date. That looks pretty good. So if a customer hasn't made a transaction for 6 months, then they are considered churned. That seems pretty reasonable to me. And it's quite nice to see that it's reusing some data in the intermediate steps. It's inspecting the data, and we can see what the output is, which is the kind of thing that you'd expect to see in a Jupyter notebook, that you're inspecting the data and doing some rudimentary analysis. There's definitely a lack of exploratory analysis, which I would expect to see in a notebook from a data scientist. More some visualizations and plots just to get a feel for how messy the data is. Is there any other pre-processing steps you might need to do to tidy it up? But it's not a bad start. Probably not useful for a non-technical user, but perhaps useful for a data scientist if it was more advanced. So it's asking me if I want to proceed with feature engineering. So that sounds good. Let's see what it can do. Right, so what have we got? It's engineered some new features, transaction frequency, average transaction amount. That seems pretty good because if you remember that transaction data is many to one, so there's many transaction records for every single customer. So it's now been able to aggregate that to calculate some new features so that the language model can use for building a predictive model for churn. Although I'll be interested to see what it does with the back of that. Even if it does train a great model for predicting churn, I wonder what it will suggest actions to take off the back of that analysis. Right, so it's now trained a logistic regression model, and it's got an outrageously high accuracy, but it's correctly identified saying that it's not performing well for churned customers. And it's identified that the dataset's highly imbalanced. It's likely causing the model to predict the majority class, which is probably correct. And it's suggesting using techniques to handle class imbalance. I mean, it's not a bad step for developing a baseline model for this dataset. There hasn't been any data cleaning though, so we don't know if any of the features are likely to be overfitting or any other issues like that. But let's see if it does improve the class imbalance. And I'd be interested to know, when we have a look at the results, has it actually created a test set, or has it just trained and evaluated on the training set? Right, so it said there's only 13 churned customers a day, so which is not many. But let's give it a go with over or under sampling first, just to see if that improves things. See what the language model will do, and then we can inspect the code afterwards. So let's give it a go with oversampling. It has also suggested using other algorithms though, decision trees, random forest, or gradient boosting, because XGBoost and CatBoost have things in place to be able to better deal with imbalanced classes. So this is a good suggestion. Right, so it's done, and let's see how it does. So it's been trying to use Smote, which is a library for imbalanced datasets. So it's tried to import it, it's failed, but then it's manually oversampled the churned customers, and the performance has now changed, but the overall accuracy is less. but the precision and recall have improved for the churned customers. So that's a good sign. The model is doing something at least, although I'm still concerned over the lack of exploration, means that the data might not necessarily be suitable. So let's have a deeper look at what it's doing. So it has separated out the training and the test set, and it has correctly oversampled them by sampling with replacement. And then it's combined the oversampled churned customers with the non-churned customers. That looks pretty good. It's trained a logistic regression model, which is a good baseline model, not anything too complex. It's best to start simple. It's making predictions on the test set, and then it has printed out these scores and a full classification report. So we can actually even then inspect the performance on those sets. And so actually the precision is very low. So the model has really not done a very good job. Although it has a higher recall, there are going to be a significant amount of false positives for our test set. But it's not a bad job. It was able to deal with part of the problem, and I could ask it to continue and it might then try and solve this other problem, but I get the impression that the approach it's using feels very guided. You're having to tell it what to do. So that was pretty neat. We've done some basic machine learning in our rudimentary notebook with a chat window. Now let's try and create some figures. So I asked it just to plot it. Bear in mind we haven't actually given it the ability to, or we haven't done anything specially to do it, but it was still created this plot window that popped up in a new browser tab, which looks great, but I'd much rather have it integrated into the chat window, so it's a bit more interactive. So that's what we're going to do next. Let's fully integrate the plotting into the chat, and then we'll be able to have a little bit more exploration. Right, in this part of the build, we're going to be setting up the plotting inline. So I want to get the plotly plots displayed in the chat window. Let's take a look at our graph to see how we're going to do it. What I'm going to do is I'm adding an extra element to the graph state, these output image paths, so that I can save to disk the plotly chart and from the front end load it back in. Let's have a look at how we update our graph. First, I'm updating the prompt, and I'm just adding these extra guidelines at the bottom so that, just to confirm, it should always use plotly for the plotting, and that it should store all the figures inside a variable that I'll create and prepare. Additionally, I don't want it to use fig.show because that's what causes it to pop up in a separate tab. So I just want it to store the figure into this list, the actual variable, so that I can then access it after the code's executed. I'm updating the back end here. Because I want to only get the new plots, I'm getting the starting image path, so the paths that already exist. It's already on this output image paths class variable. And I'm creating a set of it so that after we get the new paths down here, the new image paths, I can then look at when we get the new ones, these output image paths inside the result variable. I can then get the difference between these two sets, which gives us the new image paths, and I can then associate those new image paths with this specific message index, so I know which message it should be shown after. So those are all the changes to the state. I've made a couple changes to our Python tool as well. I've added this additional code that gets executed after the tool is finished running in order to be able to save all of the new figures, and I'm also creating a directory if it doesn't exist, and getting a list of the current image files so that we only add. At the end of the function, I'm then also updating this plotly figures list. So we always start off with an empty list for our figures. And after the execution has happened up here, if this list is in exec globals, which is the output variables, then I'm going to run that saving code that we saw at the top of the function, and I'm going to get a list of all the new image files to store on the graph state. Great, now let's have a look at how we're going to update our front-end code to display these plotly charts. Now plotly comes with a specific component for displaying plotly graphs called st.plotlychart. So it's a case of after we've displayed our messages, we need to check if there is an image path associated with that message index. So we're checking, is message index inside the output image paths, which contains our index? If it is, we're going to grab the image, all the image paths generated in that message index, and then we're going to load in the chart from the pickle file and display it with st.plotlychart. And those are all the changes we're going to make. Now let's take a look at how it does at plotting, and I'll really put it through its paces. If you're liking this video so far, please like and subscribe, as it'll motivate me to make more of this content. I've also got a Discord community if you want to get in touch with me, so check out the link to that and the repository for this code in the notes below the video. Let's get back into it. Right, so we're going to load in the data like before. Let's get just one chart, I think, because we want to test the plotting ability. Started with something simple, just getting it to plot a basic distribution of the customer's age. This is something that ChatGPT would be able to do easily. There we go, we've got a histogram of the current age. Looking pretty good, looking pretty smart. It's interactive as well, so that's already better than ChatGPT, much nicer. And when we hover over the chart as well, we get the number in that column. We can even then audit the code and have a look at what it's using. So it is using Plotly Express, the library. And it's clearly made a few mistakes, which ideally would like to tidy up, but that's okay. Let's see if we can create a more advanced plot. So I want to get it to overlay a secondary distribution on top of this one. And let's add in an extra data set as well to make things a little bit more complicated. So I want to have a look at the average number of cards that someone that age would have. So maybe there might be a correlation between our customer ages and the number of credit or debit cards that the person would have. So let's take a look. Right, it's managed to create the plot, and it's kind of confirmed our hypothesis, which is that as you get older, you do end up with more credit debit cards associated to you. So that's quite nice, and it shows a real relationship. I had to tell it what to do, but I knew what I wanted in this case. That's pretty good. I'm quite happy with that, to be honest. But I want to see if we can get even more complicated. What I'd like to see is, so I jumped over to the debug screen and we can take a look at the code, what it's using. So it has made a merge between those two data sets. It's merged and done a group by, and then created the same histogram as before, then added a scatter chart on top and updated the layout so that we have a secondary y-axis. So I'm fairly happy with that result. Let's increase the complexity a little bit, even further. See if it can do something more complicated. So actually I found it quite nice exploring the data, and I started playing around just asking it questions to plot different distributions. It becomes quite natural then to ask questions via free text. So I can see this being useful even as a data scientist, being able to query the data without having to stop and think about how you're writing the code to do it, especially for the kind of creative part, the exploratory data analysis. Right, let's try a more complicated plot. So can you create a distribution plot so that I can see the distributions of age for each number of cards up to 8? So we'll see how it does. I've been a bit ambiguous with the question, so I'm interested to see what it turns out. Look at that, great. So we've got some sort of violin plot, and it's an interactive violin plot as well, so we can see the distributions and how they compare to each other for each number of cards. It's kind of confirms what we had before, but seeing it in this setting, and because the plot's interactive and you're able to zoom in for more detail, I think really helps. So we can see on the violin plot the average age for the people who have 4 cards. And we can also see exactly what the distribution is on the left. That's great. I'm really happy with that. The other thing I wanted to try was to see if it can plot area graphs, so plotting a map with some densities on it. So let's take a look at how it does at doing that. So I'm asking more of a high-level question again. Can you help me understand where my customers are located? So I haven't directly told it to use the map. Let's see how it gets on. It's done, right, let's take a look. So it found some fields, latitude and longitude. Oh wow, it's actually plotted it as well. That's perfect. That's exactly what I wanted. Now we can see that most customers are based in the east of the states. We've got a few on Hawaii. Nice, some clear blobs around major cities. Oh, that's much better than I expected. And being able to then navigate around it and really explore because it's interactive, I think that really helps understand things a little bit better. So let's see if we can make it add an extra layer now and improve the figure again by colouring the dots depending on the customer's age. I want to see if there's any hotspots of young or old customers and if those two variables are correlated. Right, it's done it. Nice. I don't know how helpful it is, but it has done what I asked. And when we hover over the dots, we can see the age of the customers as well. 82, 85. Oh, that's great. It doesn't really look like there's any particular hotspots, but it's nice that it can do it. This is definitely much faster than me creating the figures by hand. Anyway, that's great. So we've seen it can do some more complex violin plots and it can do some graph plots. Both are interactive and I think significantly better than ChatGPT's figures. So that's a big win for getting an AI agent to do our plotting. So I'm really happy with that. Let's now get into a quick discussion around what it's been able to do well and not well, and what skills I can see as being valuable for a data scientist in the future. So I'm pretty confident that my job is safe, both from the soft skills and the technical skills perspective. From the soft skills, I think one really important aspect of my job is stakeholder communication. Being able to speak to the people who own problems across the business or who are responsible for improving things and really understand what the features are that they think causes the problem and understanding what is a real priority for the business. So I think this is something that a language model won't be able to do because it requires empathy and understanding and human communication, which you won't be able to do as well during a chat interface because you don't have all those body language cues and all the other things associated with communication. So that's definitely one thing that I'm not worried about being replaced at the moment. It also kind of jumps straight into modeling, and data in the real world is really messy. Without any sort of inspection, there's no way you can have confidence in the results. So even when asked to behave like a data scientist, it jumps straight into assuming the data is good quality and ready for building a model. It also didn't really even think about the next steps, so let alone thinking about deploying a model on the company's infrastructure. So I think that there's a long way to go until these sort of things are really solved, especially when you pair that with the soft skills and the stakeholder communication. There's also an element of responsibility, like who takes responsibility for a project if it does go well, and that would normally be the data scientist. But a language model which doesn't have memory of past conversations and isn't going to adjust its behavior based on the failures is going to be of very limited use in a commercial setting as a data scientist. Type of analysis was also very shallow. It very quickly ran through the entire machine learning process and didn't really stop to really try and understand or question that the approach that it was using was the right one. It didn't think to do any research into other people who've done similar approaches. So overall, the analysis was very shallow and is something that probably anyone could do from copying an online notebook on Kaggle. And that's not really where I think value is added as a data scientist, just copying someone else's approach because you don't necessarily know if their approach is right for your situation. So that brings me on to my last point, which is the why, understanding why you're doing the work you're doing and what value the work you're doing is adding to the business. And these are the 5 core things that I think is going to make my job safe for a long time into the future yet. We've been on quite a roller coaster building this AI agent for data science. I've had a lot of fun along the way. If you want to check out the code and how I did it, there's a link in the description below the video. Thanks for watching. If you have any suggestions of things you'd like to know or see or learn, let me know in the comments below or in my Discord community. Thanks again for watching and have a great day.